Hello guys, welcome back to Mezon African Motives. Still working on mathematics and 5. We are going to be focusing on our integration that is from the question paper which was written March 2023. That is for April 2023 exams. So if we have got we've got our question 4, if we check that was out of 25. So we want to see how we're supposed to attempt these typical questions. So we're given here to determine the integral of y with respect to x in each of the following cases that we are given. All right, we've got the first part here being 3 marks. So I'm just going to rewrite this aside. That is our question 4.11. So let us see what we are given in this case. Remember, we are given to integrate y, and y in this case is this expression that we have. That is the expression of e to the exponent of the square root of sine x. Remember, that was the square root of sine x, everything over sec x. So we've got sec x, the square root of sine x. In this case, everything is going to be integrated with respect to x. If we are to check here, we have got something that is common that we can take into consideration in this case, which is being the square root of sine x. We've got the square root of sine x, square root of sine x. So we can think of a substitution part whereby we can let this be u because it's complicated to work with and it's also common between these two. All right, so let us think along those lines to say if we are to use the substitution method, if we are to let u to be equivalent to the square root of sine of x in this case. Remember, the square root of sine x is simply means that's sine x to the exponent of a half, like this. All right, to the exponent of a half. Everything is being, the whole of sine x is being raised to the exponent of a half, is different from sine to the exponent of half x like this. This one is wrong. All right, it's supposed to be the whole of sine x raised to the exponent of a half in this case. So remember, what you need if you are using the substitution method is to make sure that this also has to carry a u. Since this one is going to be represented with u, this one is going to be represented with u. We are going also to need this dx to be written in terms of u. So that means we need to find the derivative of u with respect to x so that we can obtain an expression for dx in terms of the u. All right, so how do we differentiate this from our chain rule? Function of a function. Remember, if you're given this condition, you're going to differentiate the bracket. In this case, you consider this bracket, not what is inside. Forget about this first. You consider the bracket and its exponent. So you drop the exponent, you subtract a 1. So if we are to drop the exponents, that's a half times a 1 here, which is a half. The whole bracket is going to remain as it is. Remember, we are considering what is outside of the bracket. Then half of half minus 1 from your calculator, this is going to give us a negative half. All right, then you multiply to the derivative of what is inside of the bracket now. So you start with outer bracket, then what is inside the bracket. So if remember, if you differentiate a sign, it gives us a cosine of x, which is cos x. All right, so this is what we have on our answer, of which you can simplify further. Remember, we've got a negative there. We want to make dx the subject in this case. So let us just try to simplify and see what we're going to have. So du over dx is going to be equal to, remember, to the exponent of a negative means 1 over. So we are going to obtain, in this case, we're supposed to remain with something of this nature. All right, I want this part here. Let's just hope it is going to be clear, this part that I want. Okay, all right, sorry for that. All right, sorry for that. So like I said, I want this expression here to just simplify so that you properly see what was happening here. If you are to check, it's like we've got a half times sine x to the exponent of minus half means 1 over the sine of x to the exponent of a half. To remove a negative from our exponent, so it's 1 over. But the cosine of x is going to remain on top because we are not having anything. So it's like this. So if you have to check here, if you have to multiply 1 times the cos of x, we are going to have the cos of x everything over 2 times sine to the exponent of x, which simply means 2 sine x to the exponent of a half, which is same as the square root of sine x in this case. All right, remember we said the square root of sine x is same as sine x to the exponent of a half. So wherever we see to the exponent of a half, we are going to put the square root. But take note, there's a 2 also in the denominator there. So it is going to be 2 the square root of sine x like this. We can write it like square root of sine x. We can choose to leave this part as it is. It's your choice. All right. So the question is now, if we are to write this as the square root of sine x, all right, I'm back to that part that I don't want to see. All right. Okay. So if we are to take this, my question is, I want you to be very clear because this part is confusing a lot of students here. What is happening is that we have gotten back to the original says we have reversed everything to the original state, whereby we are having the square root of sine x, the square root of sine x here, also the square root of sine x, which is the one that we talked about in the previous class here, to say u is representing the square root of sine x. So in our own sense, if u is representing the square root of sine x, what does it mean? It means that instead of me working with x, because I want to get rid of x, that is the major thing that we want. We want to get rid of what? Of x. And this part has got an advantage because it can be replaced with a u. So meaning to say, in place of this sine x, we are going to replace our u. So meaning to say our du dx is going to be equivalent to the cosine of x over 2 times the square root of sine x, which is the square root of sine x is representing u in this case. So this is going to be 2u like this. So this is the major part that I wanted you to see, guys. Be careful about this part. You can rewrite this in terms of what you want, okay, which is the u, because it's the same as this part. But if you were maintaining to the exponent of a half, like this part, probably you were not going to notice this. All right, if you were maintaining this part here, all right, where is this part? This part here. Sorry for this. If you were maintaining what we had here, which is to the exponent of a half, it was going to be difficult for us to actually see what is happening. So that is why it is good for us to rewrite in terms of what the square root. Once we rewrite this in terms of a square root, therefore, let us make what we wanted to make the subject. Remember, our major part is to make dx the subject. All right, so we are going to make dx the subject. You can cross multiply here so that you can remove the fractions. That's dx is going to multiply cos x, which is dx, the cosine of x is equal to 2u is going to multiply du. So it's going to be 2u times the du like this. All right, so we can get rid of this by dividing by the cosine of x so that we remain with the dx. So that means that dx is going to be 2u du like this over the cosine of x. We want to get rid of this to remain with dx. So this is the expression for dx, which is fine. But as we can see also on this expression, we can simplify it further because we know that from our trigonometry, 1 over the cosine of x is equivalent to sec x. Yes, you can write as it is, but we can see that the cosine of x is in the denominator. So it means whenever we have this in the denominator, like 1 over the cosine of x like this, it is going to give us sec x. So that means we can simplify further as dx is equal to 2u du by this 1 over cos x, which gave us sec x in this case. So meaning to say there is a sec there. So with this x that we see, what we are going to do now is to substitute this value that we are given in place of what? Dx. So we need this part. The whole of this dx is the one that you're now going to substitute back to the original integral, which is 2u times du times sec of x. All right, so let us substitute into our integral here. Remember, this is where we want to substitute, or let me just try to do this so that we can properly see our answer and what we are supposed to substitute. So this is the part that we are supposed to substitute here. So we are going to have this as is equal to the integral of e. Remember, the square root of sine x is now represented by u because we said this is u over Then we have got sec x in this case. So this is going to be sec x times the square root of sine x, which is represented by u again, multiplied to dx. And this dx, now we have written this in terms of u, which is going to be 2u times du like this times the sec of x. So this is the expression now. This is the integral that we are going to work with so that we find our exact values in this case. All right, so let us try to simplify and see. Normally, if you are using the integral by substitution, you are supposed to have the part that is going to cancel, like this part, the sec of x is going to cancel with the sec of x. The u here is going to cancel with this u, not the u on the du like this. This is one term, so you do not cancel this u and this u, but this one and this one can be cancelled. So meaning to say at the end, we are left with the 2, the e, and the du. So that is going to be the integral. Can have 2 outside of the integral because the constant, that's e to the exponent of u du like this. All right. Remember that the integral of e remains as e if it is a constant term, like we are having a linear expression. All right, let me take it this way. If you were given as e to the exponent of f of x with respect to x, that means you are going to have e to the exponent of f of x like this over the first derivative of f of x plus the constant c. But in this case here, there's a 1. So the integral of the derivative of a 1 is going to be a 1. So that's why I'm saying this does not change. So that is going to be 2e to the exponent of u plus the constant of integration in this case. But knowing that our question originally was not about this integral as a whole, but it was for us to integrate this with respect to x, not with respect to u, but with respect to x. So we have to go back on our introduction. Remember, u is representing the square root of sine x. So on our final answer here, where there is a u, we are going to write the square root of sine x in this case. All right. So that is going to be 2e to the exponent of the square root of sine of x like this, plus the constant of integration. All right, so that was the basic approach that was needed in this question. As you can see, it's just a matter of play around of information in this case. If you actually understand your integrals, all these whole steps that I was showing here, you do not actually need to show all of them. You can simply see that some of these stages can be ignored. All right, let us check from our question 4.12. Again, we are given to integrate with respect to x. In this case, we have got the sine of 3x times the sine of minus 2x. All right, so let us have this aside, 4.12. So we are given in this case the integral of sine 3x into the sine of minus 2x like this. All right, so this type of an integral, sometimes they might even give you a cos here and a sine. They can give you a cos on this side and a sine. So what you need is to combine this trig into a single trigonometry. All right, if you check on your formula sheet, you have also the integral, the combination of these identities, all right, where this one is sine and sine. So from this part, we know that the sine of A multiplied to the sine of B like this can be combined into a half of cosine of A minus B. So you've got half the cosine. This is the identity that you need to take, the cosine of A minus b like this, minus the cosine of a plus b in this case. So this part is going to be a plus b like this. All right, whereby in this case, our a is represented by 3x, the whole of this part. This is our a. So here, this is your a, and this is your b. Please be careful, because on the simplification part there, sometimes your memos, they do the wrong parts there. So be careful on how you are supposed to attempt these typical questions. So here we are simply saying we are going to substitute now. If it is sine of 3x by sine of minus 2x like this, it means this is our a. Like I said, this is our b. We are supposed to have something like half of the cosine of a minus b. take note, our A is 3x. So it's going to be 3x minus, then the B is carrying a negative. So it's minus 2x like this. This is what we are supposed to have. Minus the cosine of A plus B. So it's A, our A, which is 3x. So we've got 3x plus the B, our B, which is minus 2x in this case. This is what you're supposed to have exactly. So now knowing that negative, this will give you a positive, negative and positive will give you a negative at the end. This is what you're obtaining after the simplification. The first thing was to properly substitute these values as they are. This is the first thing. Substitute your values as they are, A minus B, A plus B. So here we are now having minus from this part that was carrying a negative. That's why we're obtaining what? A positive. So if we add 3 plus 2, we are going to obtain 5x minus, here we are going to subtract 3x minus 2x, which is going to give us x. So this one is going to give us the cosine of x. So meaning to say, from these two that we are having that are being separated from a single part, this was being multiplied, it's a single term. But now we are having two terms which can be integrated, and this part we can integrate cos. So that's an advantage that we are simply taking from this. So it was just a matter of changing from what we cannot integrate direct to what we can integrate. So this whole part is the one that we have here. So we can rewrite this as it is equivalent to, so this is one in terms of our integral, it is going to be equivalent to the integral of this whole expression, which is the half of cosine of 5x minus the cosine of x, like this, with respect to x. And knowing that half is a constant, we can even write this half outside of the integral in this case, all right? So we can take this constant outside of our integral. So that is going to be a half like this. All right. So meaning to say we can be able to integrate each and every term inside. Remember that if you integrate a cos, it changes to a sine. So this is going to be the sine of 5x over, you divide by 5. All right, minus cos changes to a sine. So this was going to be sine x. It was supposed to be over 1 because here if we differentiate, this is going to give, that's a 1. So this one was going to be over 1, but over 1 does not affect anything. So you're going to leave it like that. All right, plus the constant of integration. So that's it. If you want to expand by this half, it's up to you. You can multiply this term by a half, this term by a half. This one is up to you. So you're going to obtain like 1 times sine 5x, which is sine 5x over 2 times 5 in this case, which is going to give us a 10, minus 1 times minus sine x, which is going to be negative sine x over, this one is same as over 1. So it's 2 times a 1, which is a 2, plus the constant of integration. So that is how we can simplify this at the end. But as you can see, it's also direct. It's also direct, just needed to follow the steps. All right, the first thing, so these are our calculations here. This is just part of calculations that you're supposed to make aside. Then after this, properly substitute everything into the our integral part. We can integrate everything. So that is how you apply these identities. All right. So like I said, you're also given in your formula sheet. We try to explain with the formula sheet in our next classes that can also help. All right. On question 5.13, which is having 5 marks. All right, then Trig. Okay, the cos squared by the sine cubed of x. All right, let's see why are they giving 5 marks for this? All right, let's see. So that is 4.13. All right, 4.13, that will be the integral of cos squared x. So we've got cos squared x by sine x cubed. All right, so when you are dealing with identities, you need to just understand like concepts of each part. When we are separating these cos and sine, having two exponents like this, we can try to rewrite in form of a way that we can apply a substitution method. So it's either we can, it's best actually for us to change from our identity. The sine squared can be written in terms of 2 terms, so that what we need in this case is to combine. So you are asking yourself to say you want to combine these terms. So you can make this cos squared to be written in terms of sine x, or we can relate this sine cubed, which is the best, to separate this into sine squared and sine x, so that at least we can find something that here has got cos squared, cos at the end, not cos squared actually, but it must carry a cos. So where can we have this sine carrying a cos? We know that from our Pythagorean identity, or the square identity, cos squared x plus the sine squared of x is equal to 1. So it means to obtain the sine squared of x here, we are supposed to transpose the cos squared to the other side of the equation. So we are going to remain with the sine squared x equal to 1 minus cos squared x. So this is the one that is going to represent sine squared x. But here we are not having sine squared x, we are having sine cubed x. So that means we are supposed to separate this as cos squared x times, in order for us to have sine squared, we are going to say this is going to be sine squared x times, to obtain sine cubed, it means you were multiplying again by sine x. Remember, from your identities, x to the exponent of a times x to the exponent of b, it's x to the exponent of a plus b. So there we are having 1, so 2 plus 1, that is a 3. So that is why I'm saying we are going to use 2 and a 1 on this part. All right, so with this part that we have, we are now substituting back our identity, the one that is representing what? Sine squared x, because we have sine squared x in this case. That is one that we are having here. So here we are going to substitute, which is going to be the integral of cos squared x. This sine x, there's nothing to substitute for this sine x. So we can write it here, times sine x into, now we are substituting what is representing sine squared x. And sine squared x is represented by 1 minus cos squared. So you're going to substitute 1 minus cos squared x. So this is what we have. Remember, it's with respect to x, all right? With respect to x. Let us expand our brackets and see what is going to happen, because we've got brackets. Remember, I said there is a substitution that's going to happen there. So if you multiply here by 1, we are going to have cos squared x times the sine of x, all right? Minus, we multiply this part and this part here. We are going to have cos and cos 2 plus 2, which is cos to the exponent of 4x. Remember, the bases, if they're the same, you add the exponents when multiplying. All right, but there's a sine of x there. So you're going to have the sine of x with respect to x. So this whole part is being affected by the integral with respect to x. If we are to check here, there is a substitution that can actually take place here. Let us consider this part here so that we can properly see it here. That is where we are now. If we are to check where we are, there is a cos and a sine. So it's difficult for us to change. If we were to change this, I want you to see, but someone is thinking to say, okay, what if we're just going to change this cos into a sine? You are going to obtain 1 minus sine squared x multiplied by sine x like this. If you multiply this, that will be sine x to the exponent of 3, which is fine. We can deal with that. Try to play around with your substitution method and that, which is fine. Or function of a function, just like we are going to back to the functional function concept, but under the integrals, which is somehow going to be difficult for us. So instead of that, we can choose to make this to be the subject. We can make u as our substitution, so that whatever sine x is going to happen is going to affect cos. Whatever sine x is going to affect cos. So it's a matter of choice there, not to expand or to expand, all right? So in this case, not to expand was the best way. So let us now separate our integrals. This part, we can integrate the whole bracket as it is, or we can separate. Okay, so what I'm trying to say is that let me be writing, I'm talking too much. Let me do this. So we're gonna separate here, dx, all right, minus, we integrate also this part, the integral of cos to the exponent of x, the sine of x with respect to x. Now we can make our substitution part. All right, so we can choose here to let u, so we can let u be equivalent to the cosine of x. That means here we are going to have u, here we are going to have u, right? But now remember what I said, whenever you introduce u like this, it means also dx is supposed to carry a u. So in order for you to have dx, there's no way we are supposed to differentiate this part with respect to x. So that is going to be du dx. Remember, cos, when you are differentiating now, it changes to a negative sign of x. So that's negative sign x. So we can make dx this, dx the subject. This is same as over 1 cross multiply dx times minus sine x. It's minus dx, the sine of x, equal to 1 times du, which is the du in this case. We want to find dx. So what is affecting dx is this negative and this sine of x. So we're going to divide by that. That means our dx is going to be du over the negative sine of x. But knowing that if a negative is in the denominator like this, it means also like it's in the numerator. It's just one and the same thing. So here there is sine x, there is sine x. So do not be tempted by what I explained in the previous question, where I said from that 1 over cos, where we had something like 2u du over cos, and we said 1 over cos is going to give us sec. It was because there was a sec on our question here. There was a sec. If you check here on this part, there was a sec. So that is why I had to focus with a sec. In this case, we do not have cosec. So there's no need for us to change this and say we know that 1 over the sine of x is going to give us cosec x. Where are you going to put that cosec x here? We do not have cosec x. So it's not about just always we are supposed to change this, okay? So here we are going to maintain, because this part here, we have sine x, we also have sine x here. So that is why we do not have to change. All right, so that is it, guys. We are going to have the integral of cos squared x, but cos is represented by u. So this is going to be u squared times sine x in this case, which is going to remain as it is, times the du in this case, with the dx. Our dx is minus du over sine x. So it's going to be minus du over the sine of x, minus, in this case, the integral of cos, which is u to the exponent of 4. That's cos x, it's u, multiplied to the sine of x times the dx. Our dx is minus du over the sine of x. These are the steps that you never find in your memos. They just show another step, then you wonder, where is it actually coming from? Okay, these are the stages that they'll actually be taking. So here, the sine and the sine cancels. The negative can be taken out of the integral. It's a constant, this one. So we are left with minus the integral of u to the exponent of 2 with respect to u. All right. Minus and minus here can give us a positive. So here we are going to have plus the integral of, in this case, the sine and the sine can cancel, meaning to say we are left with the u and the du. Remember the negative, we used it in the first place. So we are just left here with the u to the exponent of 4 du like this, which can be integrated. We can see this is something that we can actually integrate direct. Remember, from our integrals, if you integrate u like this with respect to, you are going to add 1, then divide by the new exponent. So if we add 1, this is going to be a 3. So we're going to have minus u to the exponent of 3 over the new exponent, which is 3, plus, in this case, u, we add a 1, so that will be a 5, u to the exponent of 5 over the new integral, the one that you are, the new exponent, which is a 5. You are now having a 5 here, you divide by that new exponent, which is a 5, all right, plus the constant of integration. But remember, this whole part that we had, it was not taken from u, it was taken from x. So our answer is supposed to carry x in this case. Our answer is supposed to be having x. So let us go back to our substitution. U is equal to what? Cosine of x. So if u represents the cosine of x, it means we are going to write this as minus the cos to the exponent of 3x, that's u representing cos x, over what? Over 3, all right? Plus u to the exponent, which is cos. So it's going to be cos to the exponent of 5x, everything over what? Over 5. plus the constant of integration. All right, so that is our final equivalent answer that we're supposed to have in this case. So be very careful, guys. When you are simplifying, be very careful on your simplification, what is needed on your integrals. All right, then the 4.14, that is again to integrate 5 marks again for this one. All right, so let us check what we're supposed to do in this case. All right, so that's the integral of 3x cubed minus 2x squared plus x minus 5 over x plus 2 with respect to x, 5 marks for that. All right, so let us set this aside and see. 4.14. So we are given to integrate 3x to the exponent of 3 minus 2x squared plus x minus 5, everything over x plus 2 with respect to x in this case. So remember that here, the denominator, as you can see, is smaller in terms of the exponent to the denominator. The highest exponent here is 1. The highest exponent here is 3. So this is called an improper fraction. In mathematics, this is referred to as an proper fraction. So whenever you're dealing with an improper fraction, you are supposed to apply the long division concept. In this case, you're supposed to divide so that you obtain the exact term plus the remainder over what was dividing in this case, which is x plus 2. So that is the condition. Here we can have plus the remainder, or it can be minus depending with what you're going to obtain. So this is the exact term that you're going to obtain after dividing. So here we are going to divide. So let us apply our long division. X plus 2 is going to be divided into 3x cubed minus 2x squared plus x minus 5. So remember, on your division, always you start by dividing the first term versus the first term. So 3x cubed divided by x is going to give us 3x squared. Whatever that you get here, 3x squared, he has to multiply everything here. So it's 3x squared times x, which is going to give us 3x cubed, 3x squared times a 2, which is going to give us 6x squared in this case. All right, then remember, subtract. You multiply back, you subtract 3x cubed minus 3x cubed, that's a 0 there, minus 2x squared minus 6. So it's minus 2 minus plus 6. So it's going to be minus 2 minus plus 6 like this, which is going to be minus 2 minus 6, which is minus 8. So this one is going to give us minus 8x squared. All right, so that is what we are going to have in the first stage. Then these terms that are remaining, we are going to drop them down. We are remaining here with plus x and minus 5. We are back again to the first step that we had, where I said when dividing, it's always the first term versus the first term. So it's minus 8x squared divided to x, which is going to give us what? Which is going to give us minus 8x. There are 2 of them. You divide with 1x, you remain with 1x. Whatever that you get multiplies everything in this bracket. That is the concept. So it's minus 8x times x, which is minus 8x squared. Minus 8x times a plus 2, which is going to be minus 16x. So this is what you're going to obtain. And after this, we are supposed to subtract our terms here. So let us subtract and see what we are going to obtain, knowing that these 2 terms are the same. So that will give us a 0 here. So here is now x minus 16x. So it's x like this minus 16x. So that will be a positive. So this is going to give us positive 17x. So here you're going to have positive 17x remaining with what? Remaining with minus 5. So minus 5, you're going to just drop it down. So that is going to be minus 5 in this case. All right. So let's check where we are. Again, we can divide here. Our concept of division is always the first term versus the first term. So it's 17x divided to x. So 17x and x, this part we just cancel. You remain with a positive 17 in this case. So that's a positive 17. This term that we are getting, we multiply it back to everything in this part, remember? So it's 17x times x, which is going to be 17x. 17 times x, sorry, which is 17x. Then 17 times 2, which is going to be 34. So if we multiply, it's 17 times x, 17x. 17 times 2, which is 34. Then whatever that you get here, you subtract, all right? So 17x minus 17x cancels. Yeah, that's a 0 there. We are left with minus 5 minus plus 34. So it's minus 5 minus plus 34 like this. This one is carrying a positive, which is minus 5 minus 34. That's minus 39 in this case. This term, if we are to try to divide, to say minus 39 divide by x, we can't divide in this case. We do not have x, so this cannot cancel. So this term is the one that is representing our remainder in this case. All right, so this is going to be our remainder. So that is the first term that we are using, that we obtained after dividing. We obtained this term. This is the exact term that we obtained. Then our remainder over what was dividing, which is what? Which is x plus 2. So meaning to say, the whole expression that we had before, this one, the whole expression, this one that we have, can be written as, so this was going to be written as, this is equal to the integral of, take note what you're going to have, the exact term. You take the exact term, this one as it is, 3x squared minus 8x plus 17. This is the exact term as it is, all right? So we are going to have 3x squared minus 8x plus 17. Then we add the remainder, which is our remainder. In this case, it's minus 34. So it is going to give us a negative here because we are having a negative on the remainder. So it's going to be the remainder over what was dividing our expression. What was dividing our expression from the whole part here? Okay, this is here from this part in our division. It's x plus 2, this part in the denominator. So it's the one that we are going to divide. So we are going to divide here with x plus 2. So this whole part, it's over x plus 2. So that was what we had from that division. This is what you're going to obtain. So we integrate everything here with respect to x. That's it. Integrate everything with respect to x. All right, so let us start with the first part. 3x to the exponent of 2. Remember, integral, you add 1. So that is going to give us 3x to the exponent of 3 over the new exponent, which is 3. So this one and this one was going to cancel. We remain with x to the exponent of 3. All right, this is negative 8x. So it was going to be negative 8x. We add a 1 here. So it's 1 plus 1, which is 2 over the new exponent, which is 2 in this case. So this one and this one was going to cancel. We get negative 4. So we are going to obtain negative 4x squared in this case. All right, the integral of a constant with respect to x, we are simply going to multiply that constant with x. So that's negative 17x. All right, then here we are going to have the integral of this part. If you are given a constant, actually, let me just explain it like this. If you are given a constant like 1 over x plus a, like this, the integral of 1 over x plus a, we know that this one is going to give us the ln of x plus a, the ln of x plus a, plus the constant. Whereby here, if we are given a constant now, like a constant k, we are going to multiply by the constant. So it's k ln x plus a. So in this case, we have got 39. So we are going to obtain 39 ln of our linear expression, which is x plus 2 in this case, all right, plus the constant of integration. But take note, if it was like a condition like this, whereby we are given, let's say it was 39 over 3x plus 2 like this, you are going to divide by the derivative of this part here. Meaning to say, in this case, we are going to have something like 39, the ln of this part, which is 3x plus 2, but you divide by the derivative of this part, so which is 3. But now, because here there is a 1, that's why we are not dividing by a 1. But in actual sense, we are supposed to divide by the derivative. So here there is a 1. So there's no effect. If we divide by a 1 here, our answer is not going to change anything. So that is why I'm saying it's not important for us to apply this division concept. All right, so that was our whole integral that we're given. all we needed here was to know the stages. We are seeing that it's an improper fraction. So if it is an improper fraction, you apply the long division concept. After dividing, rearrange your terms from what you obtained after dividing, then integrate each and every term. That is the idea there. All right, so let us check the other part, which is 4.15. This one was actually a confusing type of a question to most students there. So they're failing to understand, how is this question supposed to be done? How are we supposed to play around with this type of a question? Actually, there's a lot that we have here. And with the marks that we have there, I don't know, you see, guys, what's going to happen. Let me explain it here. So you're given to integrate this, and we are given a hint. Let u or f of x be equal to x squared. Let u be equal to, let u or f of x be equivalent to this part. This is what you're given. All right, let's see. What are they trying to say here? That is 4.15. So this is the integral of, that was x cubed. So this is x cubed, e to the exponent of x squared, like this, everything over x squared, plus 1 to the exponent of 2, okay, with respect to x, if not mistaken. Then we are given a hint that let u, or you can have it as f of x, is equal to, all right, let me check again. Let me check here. That was x squared e to the exponent of x squared. So that is x squared e to the exponent of x squared, like this. All right. So this type of a question is supposed to be integrated actually by parts. But how do we apply our by parts concept? That is the question. All right, how do we apply our by parts concept? That is how we are supposed to ask ourselves in this case. All right, we are given that u is supposed to be given as what? As x squared e to the exponent of x squared. All right. If we are to take this into consideration, we can have this separated, like, let us take this part. We want to separate this part into x squared e to the exponent of x squared. So if you are to check here, there is a x to the exponent of 3, x to the exponent of 3. So we know that x squared times x gives us x to the exponent of 3. So we're going to separate this in terms of x and x squared. All right, so that means we are going to have this as the integral of x, all right, times x to the exponent of 2, e to the exponent of x squared. Remember, this is what we want because it represents u. So you're going to separate that, all right? Everything over x squared plus 1 to the exponent of 2, all right, to the exponent of 2, like this, with respect to x. Okay. From this part that we have, we are supposed to be careful now because we are saying we are now having our u in this case. All right, this part representing our u. But if we are to check now, we can separate because we understand that if I am given like 1 over 2 times 3, it is the same as 3 over 2, like 3 times this, 1 times this. So we can even separate our terms. Like this part can be separated, this as a term and this one as a term. Okay, let me show you what I'm trying to say. We are going to separate this as the integral of, all right, we are now having 2 terms, this part here and this part. Okay, and also a times b is the same as b times a. So if I start this part here, multiplying this part here, or I start with this part, multiplying this part, it's still one and the same thing. All right, so as for me, I'm going to start with this part. The one that is representing our f of x is the one that is best for us to start with. So it's going to be x squared e to the exponent of x squared times this part that is remaining, which is x over x squared plus 1, like this, to the exponent of 2 dx. So we now have 2 terms. We've got 2 terms there that we are considering, this term and this term. So there they are saying let u be this. They want us to use by parts in this case, whereby you are going to choose your u or your f of x. So in this case, I'm going to write it as f of x, but you can write it as u in this case, which is fine. So I'm going to repeat it again here. I'm going to repeat it again here. Remember, u is equal to our f of x, which is equal to x squared e to the exponent of x. That is a given part that you were given there. So this is the one that you're going to take, meaning to say, if we say this is our f of x, remember by parts method. All right, let me write the formula for by parts. It states that the integral of f of x by g prime x dx like this is equal to f of x by gx minus the integral of the first derivative of f of x by gx dx like this. This is our by parts. So they are saying let u be equal to this, let f of x be equal to this, meaning to say you are given an option. They chose for you the f of x to use. They chose for you to say, okay, this is the one that you're going to use as your f of x. So knowing that our f of x in this case is equal to x squared e to the exponent of x squared, what do you need from f of x? Definitely from our by parts, we need its derivative. So we are going to need f prime x. Knowing that, we are remaining also with the g prime x dx, which is the remaining term that is multiplying here. We need to say this remaining term that we see here is the one that is going to represent our g prime x, which is with respect to x, is the one that is equal to x over x squared plus 1 to the exponent of 2 with respect to x, where we know that in order for us to find the gx now, we are going to integrate both sides to obtain what? To obtain this gx. To obtain this gx, we have to integrate there. So this is the most important part they were trying to hide, to say, let f of x be. They want you to obtain a by part concept where you are given an f of x to use. And from there, you have to find its derivative, which is f prime. And the remaining part is your g prime x. You find the integral to find what? Gx. All right, so let us start with the f of x. So on f of x, like I said, what you're going to need there is to find its derivative that is needed on our formula. So what is going to be the first derivative of f of x? So as we can see, this is a product where we have got u and v. So we are going to apply the product rule here, which gives us u, the first derivative of v, plus v, the first derivative of u. So meaning to say the first derivative with respect to x is going to give us u. In this case, this is our u, which is x squared times the first derivative of v. We are supposed to integrate this part to differentiate, this part. So how do you differentiate e to the exponent? Remember the derivative of e. If it is e to the exponent, let me write it like this. The derivative with respect to x of e to the exponent of f of x like this it gives us f prime x by e to the exponent of f of x. So we need the first derivative of this. The first derivative of 2x of x squared gives us 2x. Sorry, that is the first derivative of this. All right, times e to the exponent of f of, meaning to say e is going to remain as it is, e to the exponent of what? X squared. All right, plus v, our v this time we're just writing as it is, which is e to the exponent of x squared, times the first derivative of u, which is x squared. Remember, here you just drop an exponent, so it's gonna be 2x. We subtract 1, so that will be a 2x. So that is what you needed in this case. So from there, we can try to simplify further. Let us try to simplify further by just combining our terms. So that is the first derivative with respect to x, which is going to be 2x times x squared. That will be 2x cubed e to the exponent of x squared. All right, plus 2x times, you can just write as 2x e to the exponent of x squared if you want. So this is our first derivative with respect to x, the one that is needed on our formula at the end here, the first derivative with respect to x. All right, we are done. We move on. The remaining part we said is for g prime x, which is going to give us gx. So in order for us to obtain gx, we need to integrate both sides. All right, so let us integrate both sides and see what you're going to obtain from this. So by integrating both sides, we are obtaining gx in this case. Remember, here we are going to obtain gx. Now the question is, how are we going to integrate x over x squared plus x over this part here? Let me push this way, x over x squared plus 1 to the exponent of 2. All right. It follows that from this concept here, if we are given f of x to the exponent of n multiplied to its derivative with respect to x of dx like this, if you are integrating this part of f of x to the exponent of n multiplied to its first derivative, in this part, guys, be careful again. It must give us f of x to the exponent of n plus 1 over n plus 1 like this, plus the constant of integration. All right. Now let me analyze this in a way that we can understand here. I want us to analyze in a way that we understand. We are saying, if we can have this in this form, f of x to the exponent of n times its derivative, we can integrate it this way. All right. I want you to take this part in terms of exponents. I hope it is not going to be much so that you understand me. Here we are given to integrate x by this part, or x over this part, whereby this part, it has an exponent of 2, but written on top, it can carry a negative like x squared plus 1 to the exponent of minus 2 with respect to x. But remember what I said, a times b is same as b times a. So this simply means we have got the integral of x squared plus 1 to the exponent of minus 2 times x like this with respect to x. So this is our f of x to the exponent of n, f of x to the exponent of n. But they are saying multiplied to its derivative in this case. All right, so let us check what is happening here. This is our f of x, all right? Our f of x, I want you to see properly. Our f of x is equal to x squared plus 1. What must be the first derivative of this? Because they are saying these two must be the same. These two must be the same. If this is f of x, this is the corresponding derivative. They must be taken from the same term, f of x to its first derivative. So meaning to say, if we were to use this part, the first derivative here of x is going to give us 2x. But here, if we check, we do not have 2x. We have got x, not x. This one, it's not x. It is supposed to give us 2x, not x. So the question is, how are we going to have this so that it gives us exactly the 2x here? It is going to give us 2x. All right, so this is the condition that we are going to, in order for us to obtain 2 here, we need to multiply by 2. So to multiply by 2, what does it mean? To multiply by 2, it means we are obtaining 2x, which is exactly the one that we need. But the moment we multiply by 2 like this, we have changed our question. Our question has changed. So for this question not to change, we are going to multiply by 2 over 2 like this, because 2 over 2 is same as 1. So meaning to say we haven't changed our question. If I multiply this by 1, I haven't changed anything because it is going to remain as it is. So the idea is not to change our question. So we are going to multiply by 1, which is 2 over 2, because 2 over 2 is same as what? As 1. What we want to target is that if this 2 multiplies this x, it gives us 2x, so that we can apply this law, because this law, it only applies when this gives the derivative, which is exactly the same, not to say they are not the same like this one, which is giving us what? Which is giving us 2x. So I'm going to take this inside, all right? So this is going to give us This 2 here, I'm going to take it inside where there is an x here. So it is going to be the integral of, so if I remove these 2 to multiply x, it means I'm going to remain with what? With 1. So I'm going to have 1 over 2. The integral of this part, which is x squared plus 1 to the exponent of minus 2. Then this 2 is multiply this x. So it is going to be 2x like this, dx. So we have achieved what we wanted, guys, to say. This is your f of x, and this is its derivative. The derivative of our f of x is 2x, and this is our n. So they are saying f of x to the exponent of n times its first derivative. Whenever you are integrating such a condition, your answer is going to be f of x to the exponent of n plus 1. So you don't even care of what is going to happen inside this integral. This is the law that you are supposed to know. This is the rule that you are supposed to know. So meaning to say on this part, we are going to simply take this, all right? We are going to simply take this as, all right, so here we are going to have 1 over 2 is not even affected. It's not part of our question, this 1 over 2. We are worried of what is inside the integral. So we are saying our answer is supposed to be f of x, whereby our f of x is this bracket of x plus 1, of x squared plus 1. So we are going to have x squared plus 1, all right, to the exponent of n plus 1. Take note, n plus 1. So meaning to say we are going to add, this is our n, which is minus 2. So we are going to add now 1, which is going to give us what? A negative 1 over what? Over n plus 1, which is the same minus 2 plus 1, which is what? Which is minus 1. That is how you integrate this whole part. You add the cost of integration. Guys, as long this is f of x, and this is the corresponding first derivative, if these two are the same, to say, not to say they are the same, but if this is taken from f of x, this is the rule. So follow the rule, just like how you know to say, if you integrate sine, you get a negative cos. If you integrate cos, you get a positive sign. This is the same thing with this law or this rule that I'm saying. If you know that these two are corresponding, this is f of x to the exponent of n, but this is the first derivative of f of x, therefore apply this. So this is what we saw. This is your f of x. This is the first derivative of f of x, which is 2. But if we saw here, we are not having x. So to multiply by 2 over 2 was for us to obtain this as 2x, because we can see that our answer was supposed to be 2x. So that is what we're supposed to obtain, guys. So we can simplify so that we can just have our answer in an exact format. All right. So this, let us simplify. We can just have this as here inside 1 over, and so this is negative 1, can just multiply this side, which is a negative half like this, but here it's 1 over, all right, to the exponent of negative 1 means 1 over x squared plus 1 like this. All right, so this can just be written as negative 1 over 2 into x squared plus 1. Remember, if you are finding gx, if you are finding, because this here is taken from what we want here, guys, we are on gx, we want to calculate gx. So if we are calculating gx, there's no need for us to have the constant of integration. We are just going to take this part as it is. So this now gives us our gx. All right, so we are going to take this into our gx. Remember what we got, guys, don't forget this answer. So our answer here, we got negative 1 over 2 into x squared plus 1. So as time goes on, all these stages that I'm showing you, these are the proper stages that you were supposed to take. But if you understand these rules, guys, you don't need, you can do it by looking into the question. You can tell what is happening, of which we can bring that in our next video so that we can see or learn how to integrate like that without wasting much of our time. All right, so this is what we got, and here what we are going to simply do is to go back now. Remember, we are integrating by parts, and this is our formula for by parts. From this part that we had, where we have got f of x of this is going to give us f of x by gx in this case. All right, so meaning to say we are going to combine everything now from these values that we have. F of x, we have f of x, so this whole part was going to give us All right, so I'm going to take, all right, let me just rewrite as it was before. So this one was the integral of, all right, as it was before, this one as it was before, the integral of this part here as it is, all right? So that is the one I'm just going to take. Now we want to write the answer, or we want to obtain the answer here. So this was going to be, all right, let me just use another one so that it can be clear here. All right, let me choose this. So it was the integral of x cubed e to the exponent of x squared over x squared plus 1 to the exponent of 2 dx. So we say this is going to give us from our by parts method f of x by what? By gx. And our f of x here, it is, that is x squared e to the exponent of x squared. All right, so we are going to have x squared here, e to the exponent of x squared times gx. Gx is the one that we calculated here. Sorry, remember our gx, we have it here, which is -1. So we are going to multiply -1 over 2 into x squared plus 1 like this, all right? Minus, remember on our formula, we are going to subtract. What are we going to subtract? The first derivative of f of x. So we're going to subtract the first derivative of f of x into the integral in this case. So it's just a matter of, so here f of x is just a substitution, because we are, our f prime x we have already, as we can see on our formula. So you can just substitute our f prime. So at the end, you see that this question with the marks, it does not correspond, but maybe it was just for the introduction of the question. They didn't check much on it, but does not correspond. Anyways, let us have our f prime x, which is, in this case, we got 2x cubed. We can even factor out what is common, all right? So we've got 2x cubed e to the exponent of x squared plus 2x e to the exponent of x squared again. So this is our f prime x. So I'm just going to put this in a bracket, or I can just leave it like that, or just put in a bracket like this, then multiplied to what? To gx. So our gx, remember, this is our gx here minus this, all right? Minus 1 over 2 and this one. All right, so we're going to multiply to our gx, which is -1 over, this is 2 into x squared plus 1, and everything multiplied to dx. So this is the whole procedure that we needed here to find our gx. In this case, having our gx, going to our first derivative of x, all this part was going to sum up to this whole integral. So this is what our question was all about. So let us now integrate our final stage. So here we can just combine the numerator. This is the same as over 1. Just multiply numerator to the numerator. So you're going to have negative x squared e to the exponent of x squared over, this is 1 times this bracket, which is going to be 2 into x squared plus 1. All right. On this other hand, you are supposed to integrate. So you can just take stage by stage this one, and this one can multiply. It's outside of the sign. In this case, it's a multiplication. This term here, like as it is. So you can even take the negative out and multiply to that, so that it becomes a positive here. All right, so I'm not going to waste much time here. We can, since we've got x squared plus 1, we can see that we can have that here if we factor out what is common. If you factor out 2 here, x is also common, so you can factor out 2x, all right, and e to the exponent of x squared, which is common. So if we factor out this one and this one will cancel. X cubed divided to x will give us x squared. All right. This one and this one will cancel, plus 2x and 2x will cancel, as this whole part and this whole part actually will cancel because they are the same. So that means we are going to obtain a plus 1 in this case. So this was the whole term that we're going to obtain here. Everything over 1 like this times this part that we see, which is 1 over 2 into x squared plus 1. Remember, we have taken the negative out. So that means these we're going to cancel. If we have to check x squared plus 1, x squared plus 1, the 2 here and the 2 here was going to cancel, meaning to say we're going to remain with this part only under the integral. So we're going to integrate x e to the exponent of x squared with respect to x. All right, with our respect to x here, by our integrals, we can be able to integrate. If we can actually, if you know this answer, actually this one, we can tell that if this is x squared, that will cancel, and we are going to remain with x also cancelled. But how we can actually apply our substitution method here, because this has got x squared, which can cancel with x here. So we can have this as from our substitution, let u be equal to x squared in this case using substitution. So that's du dx is going to give us 2x. Remember, I want to remove this dx, so make it the subject, cross multiply 1 times du. That is going to be a du here. Dx times 2x, we are going to have 2x dx. So to remain with the dx here, we're going to divide by 2x. So it's going to be du over 2x, which is going to cancel this part like I was saying before. So it means at the end, this part was going to give us the integral of x times e to the exponent of u, in this case representing x squared, times the dx, our dx being du over 2x like this. So definitely this was going to cancel with this, and we are remaining with 1 over 2. So this is same as 1 over 2. You can take it outside of the integral, which was going to be 1 over 2. The integral of e to the exponent of u with respect to u. I explained this one before, that e to the exponent of u is going to remain like that. So meaning to say at the end, our answer from this whole part was going to be equal. This part we are not integrating already, it's in simplest form. So we just rewrite as it is e to the minus x squared, e to the exponent of x squared, everything over 2 into x squared plus 1. And we got here a positive, as we said. So we are going to have the answer now after integrating. We said e is not going to change. So e is going to remain as it is, which is half e to the exponent of u. But our u being what? Our u being x squared. So meaning to say, substituting this on our answer, we are going to have half of e to the exponent of u, which is to the exponent of x squared. Everything plus the constant of integration. We are done integrating. So that was this question that you are being asked was going to give us this answer at the end. And like I said, it does not correspond properly to the marks. Even if I was to explain this in a shorter way, like I said, we are going to see that in our next classes that we shall have. But the issue of marks and everything here was not well for me. I don't know how do you see it? How do you actually see it? But this was what you actually needed. All right, something like this. Okay, let's just hope it's fine for us. All right, let us check the other part of the question on 4.2, where we are asked to determine or to resolve this into partial fractions by to integrate this by resolving the integral into partial fractions. There we are told what to do to use partial fractions in this case. So remember, from our partial fractions, we are supposed to have our denominator being factorized. And also the first thing is to check if our denominator is having the higher exponent than the numerator. So this is actually fine. This is 2, this is 1. So this is referred to as a proper fraction, not improper like what we saw before, where we had an improper fraction here, where the highest exponent was on the numerator. There you apply long division. But in this case, you express it by parts because it's a proper fraction. So you have to make sure that your denominator can be factorized in this case. So we are given the integral of 11 minus 3x, everything over x squared plus 2x minus 3 with respect to x. So by expressing this into partial fractions, what are we going to have? we are going to have 11 minus 3x over, in this case, all right? So this can be factorized. Just check for two brackets. Since the coefficient of x squared is 1, from our mathematics N2, we are going to have x and x here. We focus with a constant, which is minus 3. What are the factors of minus 3, which gives us a positive 2? We need factors of minus 3, but these factors should give us a positive 2. So that's 3 and negative 1. So meaning to say we are going to have plus 3 and here minus 1, or minus 1 plus 3, whatever way or order that you want. So as you can see, this is a linear. We've got two brackets, so it's a linear. We've got linear factors. So our bracket is going to be a over the first bracket, which is x plus 3 plus b over the second bracket, which is x minus 1. So let us resolve and find the values of a and b. So taking our numerator, which is 11 minus x. So 11 minus 3x is equal to a. So it's going to be a times what you're going to have if you divide. So this x plus 3 and x plus 3 will cancel. You remain with x minus 1. So you're going to take this x minus 1, all right? So that's x minus 1 plus here we have got b. So if you do the same thing, the x minus 1 and the x minus 1 will cancel, meaning to say there you remain with what? You remain with x plus 3. So we are going to have x plus 3 in this case, letting each bracket to be equal to 0 so that we can have the exact values of a and b. So here we can let this x minus 1 to be equal to 0. So x there must be a 1. So meaning to say when x is equal to 1, this bracket is going to give us a 0. So we put a 1 here. We find the values of a. So 11 minus 3, that's 8, is equal to here. That's a 0. Put a 1 here, 1 plus 3, which is 4b in this case. So divide by 4 by 4. So b was going to give us a 2. With the same concept we are going to use here in this bracket. If we let this bracket to be equal to 0, x plus 3 equal to 0, x will be minus 3 there. So when x is minus 3, it means this bracket is going to give us a 0. So here we are going to substitute minus 3, which is going to give us a 20. 11 minus 3 times minus 3 is going to give us a 20 in this case, equal to, here we now have minus 3. Minus 3 minus 1 was going to give us a minus 4a. Divide by negative 4, we obtain the value of a, which is negative 5 in that case. So substituting back, it means this whole integral that we had here can be given as, because we expressed this into two fractions. So we're going to have the integral of it's a over x plus 3, of which our a is negative 5. So we are going to have negative 5 over x plus 3 in this case. All right. We move on to the next term, plus b. Our b is 2. So it was going to be plus 2 over x minus 1. This is what is corresponding to 11 minus this, all over this. It's corresponding to this part. And we got the values of a and b. So these are the ones that we use here. From there, we can integrate just like the previous case. This one that we had, it was an integral. So we have to integrate our final part here. So let us integrate and see. Remember, I talked about the integral of a fraction like this from that long division. So meaning to say here, I'm not going to waste much time. Let us have our answer. So we're going to have minus 5 into the ln of the denominator. Since this is there's a 1 there, so there's no need for us to divide by anything. So it's going to be ln of x plus 3. Plus 2 into ln, also here there's a 1, so it is going to be x minus 1 plus the constant of integration in this case. All right, so that was the whole part of our question. As we can see, guys, it's very, very important, very important to obtain these marks on our integration, and that is possible. It's very, very possible for us to obtain these 25 marks. All we need is to work on each and every integral, know the basics of each integral. And also this type of a question, if you check, they are asking this type of a question mostly now where they give you a hint. So I just hope with time they are going to revise this question so that the calculations and the number of marks will correspond. But for the meantime, these are the calculations that you're supposed to make, or these are the integrals that you're supposed to understand in your syllabus. Substitution method, the part of the algebraic substitution. Check the video also that I did that one on the algebraic substitution and also on the long division, so that you understand these basics, where are they taken from. But for now, guys, that's it from Maths on African Motives. Till we meet again.